Assalamualaikum warahmatullahi wabarakatuh. Now we are moving to the next lecture, which is a lecture for chapter 3. If you can refer to your main textbook by Branson, Macroeconomics, then you can see this chapter, Introduction to Income Determination, specifically the multiplier. And what you're going to see in this chapter, in this topic, are the things that you have seen during your undergraduate study of macroeconomics. What makes it a little bit different is that you can see a substantial use of mathematics in this module. Okay, so let's crack on. So in the previous chapter, if you can recall back, you did revision on national account identity. And then you have seen this expression. Look at expression 1 here. This is not something new. On the left hand side here is actually expenditure side, and on the right hand side here is what you can do with your income, which is GNP. Now we want to make some modification on this equation in terms of assumptions. Okay, in terms of assumptions, again we want to make some modification for this expression or identity in terms of assumption. Now if you look at R here, previously in chapter 2 I did mention to you about R, where R is probably rental income or other types of income received by household. And then now let's assume that this R is actually foreign transfer payments. And to be more specific, like I said previously, there are some people who are working outside, okay, our Malaysian working outside, and they receive income, they bring it back to Malaysia. They receive income because they contribute to the production process in foreign country. Right, so they become one part of factor of production in the production process in the foreign country. So of course they will receive income, and then they transfer the income to Malaysia. And let's assume that there are not many Malaysians working outside, okay, and relatively speaking it is true compared to, let's say, people from Bangladesh, people from Indonesia. All right, so let's say they are very small in number, very negligent in terms of number, very marginal. So because of that, let's assume that the receipt of this kind of income is very, very small, up to the point that it can be approximated to zero. And then at the same time, we don't have international trade happens in this country. So if there is no international trade happens in this country, that means export and import is zero. Okay, so in other words, assumption in A says that we don't have any connection with outside world at all. So what types of economy is this? This is what we call closed economy. All right. And at the same time, for simplification of calculation, let's assume that there is no depreciation at all. So we don't care about replacing old machine. Because of that, then it is very clear that there is no depreciation expenditure at all. So this one is equal to zero. So this is the second assumption. Now let's move to the third assumption, in which we assume we don't have indirect taxes. So if we don't have indirect taxes that is not directly to the factor of production, okay, so because of that, then the implication is that we will have what we call NNP equals to GNP, okay, and here GNP equals to GDP, isn't it? Okay, so this, all right, and here look at the last assumption. All corporate profits are paid out as dividends. Okay. Also, there are no retained earnings or corporate tax payments, and there is no valuation adjustments. So any kind of tax that is not related to factor production, they are taken out. All right. So in summary, if you can go back to previous chapter, then you can see we have calculation of GDP. after plus of net transfer income, then we can have GNP, and then plus minus something here, and then we can have, NNP, in this case this one, okay, B and C, and then after plus minus, okay, I bring it here, yeah, and we can have NI. Okay, so you can see here this one is 0, this one is 0, this one is 0, so you can see GDP equal to GNP equals to NNP equals to NI, because all of this assumption meet a 0. All right, so this is what I said to you just now. We can have the following. Okay, C plus I plus G, you can see X minus M is no longer there because we don't have international trade at all. And then on the right hand side here, we don't have R anymore. And identity says that whatever being spent is equivalent to whatever being received here. Right? So this is what I said just now. So we have net national product and I and whatnot. Okay, so these are the assumptions that we need to make. If you look at equation 2 here, it is in the nominal term because all of them are in capital letters. Alright, so it is measured in current price level. So we haven't taken out the inflationary effect. So that's why all of this is in nominal terms. I hope by now you should be able to understand the term, the meaning of nominal, and compare with the real term. Yeah, this is what you should do in your revision in the previous chapter. Okay, now if you look at this nominal term here, as you can see, okay, if you can recall back previous chapter, we have nominal GNP divided by real GNP equals to price level. This one is in 100. Okay, but if you put multiply by 100, this one doesn't appear. You get what I mean here? But anyway, let me erase this. Okay, let's say it is in the form of hundredth. So if you cross multiply, okay, if you cross multiply, what do you get here is that we have nominal GNP equals to price level multiplied by real GNP. So nominal GNP is capital Y. Price level is P multiplied by small letter y. Remember? Alright? So in this case, if we try to convert it to real GNP, it becomes Y equivalent to capital Y over P, isn't it, in hundredth? Alright? So we can also convert all of these components in real term using this kind of formula, yeah? So instead of income, you substitute it to nominal consumption. Instead of real income, you substitute it to real consumption. As long as you have CPI or producer price index or GDP deflator or GNP deflator, then you can find the real income and vice versa. Okay, so this is what I said to you just now if we were to summarize it. Okay, and expression 2, like I said earlier, is in nominal term. So it is measured in current price levels. So it is also known as nominal GNP or money GNP. And like I said earlier, this nominal GNP has two components: price component denoted as capital P, real output component denoted as small letter y. So in the form of mathematical expression, it can be written as expression 3 here. Capital Y, which is nominal GNP, is equal to price level times real GNP. So like I said earlier, if we deflate each and every component of expression 2 here, we can reach to the real term of these components as expressed in expression 4 here. Okay, you can see real consumption, real investment, real government expenditure, real income, and on the right hand side of the income, real consumption, real saving, real tax values. Okay. Now let's crack on to the component owned by household. Let's recall back what we have learned in expression 4. C plus I plus G in real terms equals to C plus S plus tau. So if we cancel both sides, cancel C on both sides, then we are left with this, then we can have expression 5 here. And in expression 5, I'm sure you have seen this before, in a nominal term, on the left hand side here is injection, and on the right hand side of equal sign is leakage. So here we can see the saving investment balance here in the basic GNP identity, and then you can see here on the leakage side shows you how much the amount of real output that does not go to consumer expenditure. So they save and they pay taxes, so of course they don't spend this money for their expenditure, yeah, and it must be equivalent to the other types of income, which is on the left hand side here. So in other words, okay, injection equals leakage. So if we bring G to the right hand side, or we subtract G on both sides, then we are obtaining this, yeah, R equal to S plus tau minus G. So what does it mean by this expression 6? Can you figure it out? I want to focus on this bit. This bit is where you can see net taxes minus government expenditure. And this is not something new, yeah? How do we call this? What happens if net taxes minus government expenditure more than 0? Alternatively, we can also write it this way. Net taxes tau is greater than G. Net taxes revenue is more than government expenditure. Then we have budget surplus, isn't it? So that's why I say to you, it's not something new. So you should know what does it mean by T minus G less than 0. You also should know by now T minus G equals to 0. What does it mean? Alright. Now, let's move on. We want to look at this component. And if we want to study this component, we need to study in detail. In particular, we look at this, yeah? So, like you see, we want to look at the component of investment of the left-hand side or expenditure side. To look at the investment here, we need to study the planned and also realized investment. Now, all of these are not something new. This is just revision from what you have learned during undergraduate study. Now, this component, which is represented in expression 4 and 5 previously, can be further studied using the concept of intended and unintended inventory. Okay, so here, our investment expenditure, real investment expenditure, consists of intended and unintended inventory. Intended inventory is given by I bar plus unintended inventory given by delta I and V, right, which is expressed in expression 7 here. Okay, so when it is intended investment, what does it mean by intended investment? It's actually the producer's plan, or assume that you are the firm or the producer or the owner of the firm. Of course, you intend to invest certain amount, use that amount to produce goods and services, and then sell the product in the market. Okay, so that is what we call intended investment. However, what you intend to invest in your production process sometimes, or most of the time, is not the same what happens in reality. Why? Because of the existence of unintended investment. I give you one scenario here. Let me use red pen. Let's say you plan, you as producer of the firm, you plan to invest, let's say, equivalent to 10. So you produce product, you higher level produce a production equivalent to 10 billion, for instance, and then you sell the product in the market. But when you sell the product in the market, it so happens that during that time, demand increases more than what you have by 5, for instance, yeah? And then you can see that means the stock is not enough by 5. When the stock is not enough by 5, that means there is unforeseen changes in inventory by 5. There is a decreased amount of unforeseen changes in inventory, not enough. Okay? Then this is what we call unintended inventory decrease. Okay? So decrease in unintended inventory. When we have decrease in unintended inventory due to high demand here, what you intend to invest is not enough. That's why you have decrease in inventory. Okay, not enough stock. Because what happens here is that the actual sales has increased because of high demand. And therefore the actual sales is more than what you expect. What you expect is what we call expected sales. You get what I mean? So that's why you have unintended inventory is decreasing in the factory. Okay, so here I'm referring to this story actually, yeah? So if we look at number 3 here, you can see change in inventory is negative because of the demand, then you don't have enough stock. Remember? So we have unintended inventory decreases, right? Because actual sales is more than expected sales. You expect less sales, that's why you invest less here. But then it turns out in the market, in the economy, demand increases. Okay? When demand increases, the actual sales following the demand, which is more than the expected sales. You expect less, but the demand has increased. That leads to increase in actual sales more than expected sales. So we have number 3 here. Okay, now the increase in inventory here, the decrease in inventory here, which is unplanned. So the term change in inventory here is also known as unplanned inventory changes. So I have explained to you the scenario for number 3. Now why don't you look at these two scenarios, try to explain it like the way I explained it to you. So let's go back to expression 7 here. Now we want to use expression 7 back into expression 5 and also expression 4 here. So that means we just want to substitute here with its specific formula or equation. Then what happens is it becomes like this. Can you see? So this is actually I, because I, investment, is actually equivalent to planned investment plus unplanned changes in inventory. So we just need to substitute it back into equation, then we get equation 8. So if we add back C on both sides, then you have equation 9. There's nothing new here except that we specify the investment further. Can you see? If you look here, we specify the investment further. So on the left hand side is nothing new but this. So this is national income identity in real term after we specified investment. If we look at expression 9 here, we can see, like I said earlier, investment has been specified using this equation. If you look at this, okay, compare with this is the planned, this is unplanned, isn't it? So unplanned can change, because of a situation in the economy. The plan here is being decided by the producer. Unplanned again can change due to the circumstances and the economy. So The term delta investment here is the balancing item in expression 9. So how does it work in this case? Let me erase the mess first. So here, erase the mess first. So here, in the equilibrium equation, we can see this term. Look at the equality here. If we want to talk about equilibrium, we know that left-hand side has to be equal to the right-hand side in it. Now, what happens if there is unintended change in inventory here? Let's use my previous case in which we have increase in demand, therefore unintended inventory decreases by 5. Because increase in demand, then expenditure will be more than the output produced. If this happens, this one has to change, isn't it? Okay, so that it can balance out the left hand side and also the right hand side. I'll explain to you more using graph later because we want to talk about the leakage injection later in the form of graph as well. Alright, now we want to study the household side first because if you can recall by the equation, on the expenditure side we have C plus I plus G. So you want to look at the consumption side first. For consumer, once it receives or household, once it receives income, the person can use it for consumption, can use it for saving and pay taxes, isn't it? Okay. Let's say the person has paid taxes, so pay out of his income, then you can have this. This is what we call disposable income. So these are the things that you already knew when you studied your undergraduate level. So let's crack on. So we want to focus on the household side. We want to look at the tax side, consumption and saving. And the tax that we want to look is what we call income tax, yeah, for household. So before you can consume and save, you need to pay tax. After you pay tax, you're left with that income, which is we call disposable income. So before we explain more about consumption and also saving, let's look at the tax here. What kind of tax do we have? We have income tax. So when we have income tax, tax here is a function of income. Tax here depends on income or real GNP. In equation form, it can be expressed in expression 10 here, in which tax is a function of income. Tau refers to tax Greek letter, is a function of income. And if we differentiate tau with respect to y, equals to tau prime, which means differentiation of tau. And based on theory, it is positive because if income increases, real income increases, then tax on income is also increasing. Now remember, this tau is in the form of amount, like, let's say 100 pound or 100 ringgit, not in the form of rate or percentage. So tau here is not tax rate, yeah? Now, how do we know that it is positive in nature, which is described as this? Because, if you look at the function here, it is a generic function, not a specific function. Do you know the difference between a specific function and also a generic function? This is a generic function. What you learn in your high school up to your undergraduate level, perhaps first year or second year, is what we call specific function. For instance, if we have tax equation, then we have 0.5y. This tax equation is very specific. If you differentiate it, it is very clear. Delta tau over delta y equal to 0.5. That means if tax increases by 1 unit, 1%, if income increases by 1 unit or 1%, again, instead of tau here, if income increases by 1 unit or 1%, then tax collection increases by 0.5. That was it mean, yeah? Okay, so this is very clear because we have specific function. But what we have here is not a specific function because we don't know by how much it increases. We just know that tau depends on y because in this generic function, we know that tau depends on y based on this specification. So when we differentiate it like this, which is equivalent to this meaning, the question is, how do we know it is positive? Because we don't even know the value here in it. It is not shown to us. So this kind of value in the study of economics is based on theory. Okay, theory of economics. The more you read, the more you know the sign here. Okay, now let's crack on. Because we want to talk about household side, so we want to look at consumption and saving, right? Then we know that each household receives income, and income here can be either consumed or save or pay tax. All right. So here, if we bring it tax here to the left hand side, it becomes y minus tau equals to c plus s. And this y minus tau is actually, you have learned it before, it's called disposable income. So when you learn in undergraduate, that's why you see this, yd equals to c plus s. You can see here is that disposable income for any household can be utilized, can be disposed as consumption and also saving. Now let me erase this because it becomes a mess, yeah? So here, if you look at expression 12, let me erase first. Guys, it's very hard to explain with a mess. Okay, so if you look at expression 11 and 12, you can see consumption and saving. And consumption and saving here are specified further. In particular, if you look at consumption here, consumption is a function of disposable income. Okay, how do we know? Okay, you look here, y minus tau, we call it disposable income. And we know that tau here, which is tax, also depends on income. As income increases, tax increases in value received, isn't it? So if we want to specify it further, it can be y minus tau as a function of y, can you see? And we know that only this disposable income can be utilized for either consumption or saving. Okay? Before we pay tax, we cannot consume. We need to pay tax first, then only we can have disposable income to be consumed or saved or some other things, whatever you want to do with it. Okay? Now, so here, consumption is a function of disposable income. But because disposable income is further specified like this, and because disposable income contains tax, which is denoted as tau, and we also know that based on theory, tax depends on income, then we can rewrite it specifically like this. But still, this is a generic function, not a specific function. This is a generic function, but it is detailed out in the form of, consumption as a function of income, tax as a function of income. Can you see? Similarly, it goes to saving. All right. Now here, let me write it in a blank space or whiteboard here. Again, we know that if we have income in an economy, income received by factors of production can be consumed, can be saved, and also paid tax. Okay, if we rearrange it mathematically speaking, then y minus tau equals to c plus s. And this one, in the undergraduate level of study, we call it disposable income equals to consumption plus saving. And if I try to simplify, not really simplify, but detail it out, given, okay, 11 and 12, okay, number 11 and 12 in the previous slide refers to consumption function and saving function. And let me specify this equation. Let's say we call this one equation 12a for simplification. Yeah. So we have this 11 and 12. Okay. Substituted into 12a yields the following: y minus tau as a function of y equals to, c as a function of disposable income plus saving as a function of disposable income. And here we call it 12p. Okay. Now, let's go back to this slide. Now, we want to know how to get MPC and MPS from 11 and 12. And what does it mean by MPC and MPS? I'm sure all of you already know the meaning of MPC and MPS. But here, before I go in detail on this thing, let's look at them in the form of graph. So let's say I change the color of my marker and I put in a simple drawing like this. We have income here, we have consumption here. Basic maths that you already learned in the undergraduate level is that if you divide the first quadrant into two, like this, and then we have 45 degrees here, whatever here will be equal to whatever here if both here hits this line. For instance, let's say here is A, so here is also A amount. Let's say A equals to 5, this one also equals to 5. But if you talk about this point, okay, and you talk about this, which is not on the 45-degree line, and then A5 here, then this one is B equivalent to, let's say, 7. Okay, simple as that. Now, I want to put consumption function in the form of graph. So this is just revision, yeah? So here, what I can do is, let me rewrite again the consumption function. C as a function of disposable income, okay? I want to know whether the consumption function is upsloping or downsloping. So basic thing, differentiate C with respect to income. Then it can also be rewritten as C prime of this. We don't know the exact answer because this is just a very generic, the most generic mathematical function. But we know that if income increases, okay, consumption will increase in the economy based on the macroeconomic theory that we have learned. And this macroeconomic theory that we have learned has been validated by data, by economists previously, such as Keynesian economists. So we have positive relationship between consumption and income. Similarly, I also want to put saving function here. So whenever we talk about consumption function of a household, we will also instantaneously talk about saving function of that particular household. In this case, at macro level, for the whole households in the economy. So we have S as a function of disposable income. Again, this function is a generic function, very generic function, such that you don't even know the exact answer in mathematical form, except you can only have this sign. So differentiate S with respect to income is also S prime, and then it's also positive because based on economic theory, if income increases, then saving also increases. Now, because of that we then we know that we can have both consumption and saving function positively related with income. Therefore, it is upsloping. And how do we know that it is a straight line? It is a straight line if you know how to differentiate it second time. Okay. Then the answer is 0. That means the slope is constant. Similarly, this one, 0. It is upsloping, but it is constant, so it is a straight line. Okay. And if I draw it, consumption function looks like this. Alright. And saving function looks like this. Okay. Now, this one is A, autonomous consumption, minus A because you use all of your available saving for consumption. Now, I don't want to explain to you what does it mean by autonomous anymore because this thing has been learned at the undergraduate level. Alright. Okay, so we know that both of them are upsloping. Next, what we want to look at is, this is a very simple economy in which you don't have any other people except household. But now we want to look at an economy in which it's, having private sector at least. So we must include investment. So let's try to duplicate in this graph. Right, now we know that investment shown previously, okay, and looks like this, isn't it? Real investment. So we have consumption, we have real investment, and we have saving. Okay. At the same time, we have tax here. Okay, that affects consumption, saving, and income. Let's assume no government expenditure for simplicity for a while. Yeah. Right. So we have the graph here, and we have income here. We have 45-degree line that determines the equilibrium position. Also, we have aggregate expenditure here. Now, investment here does not depend on income. It depends on other factors. Can you determine other factors? Okay, these things you have learned in macroeconomics in your first year or second year. All right, so I'm not going to explain to you. So what's the implication of this if we try to put it in the form of graph here? The implication is that regardless the level of income, investment is always the same. Let's say if it is 10, it is 10. You get me? All right, now. So let's say we have this much of investment, call it I. Can be 10, can be anything. And right? So that means our aggregate expenditure consists of 2, that is consumption plus investment, isn't it? Right? Now, if I try to put this aggregate expenditure curve here, then it becomes like this. Okay? C plus I equals to 8E. Right. Now, we know that in equilibrium, injection must be equal to leakage. Can you see in this case, injection is only I because we don't have G, but we have two leakages, two leakage components, S and tau. So here if I try to put S and tau in the form of graph, it may look like this. Look carefully at the way I draw it. So S plus tau intersect with I at this point. I call it point Z prime. And here I call it point Z. And here is what we call equilibrium income. Now let's look at point Z and also Z prime. At point Z, aggregate expenditure curve, which is C plus I, hits 45-degree line. Remember the maths concept. Any line hits 45-degree line. The value here must be equal to the value here. So that means the value here, C plus I, let's say A equals to Y equilibrium. That means C plus I A equals to Y equilibrium. Whatever being spent is equivalent to whatever being produced. This is at Z. And at Z prime, we can see that I equals to S plus tau, another way of looking at equilibrium, and it gives us equilibrium income of Y equilibrium. Now if you look here at Z, this is the equilibrium point using expenditure approach. At Z prime, this is equilibrium point using injection and leakage approach. So we can see two approaches or two methods must yield the same results. Before I proceed to the introduction of government spending in this module, let's look back at the injection leakage equation here. If I try to specify it further, let me use red pen. So we can specify it like this. Investment equals to saving plus tax, isn't it? I'm sure by now you should know what is this. You should know what is this and what is this. Now we want to introduce government expenditure. So government expenditure is a component of injection, so I introduce it here. Alright, that means injection component in the form of curve here must change because of introduction of G. Before we put it in the form of graph, can we say that G depends on income? No, because if it depends on income, nobody wants to vote the government. As simple as that. Alright, now, because of that, G is, it's not a function of income. Therefore, regardless what happens to income here, to the right or to the left, then G is constant. So if you add to I, then it increases like this. Let's say, I plus G. Alright? Then it means, because G is also a direct component of E, remember? C plus I plus G is a direct component of E. Then AE here should increase, should shift upward by the amount of G. So here, the change in I and plus G is by the amount of G. So here, C plus I also shift upward by the amount of G. Now you look at my drawing. Okay, so C plus I plus G equals to AE prime. Now, let me fix a little bit here because it doesn't look parallel. Okay, alright, so you can see equilibrium income increases to y prime, and here equals to this, okay, c plus I plus g, p for instance, and this I call it w, this one I call it w prime. All right, so that's how we put it in the form of graph. So if I were to put it in a form of equation, then we have I plus g equals to s plus tau. All right, so specifically I bar plus change in investment equals to s as a function of disposable income plus tau as a function of income. So this is equilibrium using leakage and injection approach. But if we use expenditure approach, then it becomes C plus I plus G equals to Y. Okay, so C is a function of disposable income plus investment plus G equals to Y. All right. So, and if we try to look at it analytically, let's move to this slide. This is what I said just now. If we have equilibrium, then we can have saving investment balance, which is depicted in equation or expression 8 here. This is investment and this is G equals to S plus tau, isn't it? Now, this term should be equal to zero so that this equilibrium holds. Otherwise, if we have this not equals to 0, it can be, that means it can be bigger than 0 or less than 0. Then there is disequilibrium because of unintended change in inventory. Unintended change in inventory leads to aggregate expenditure not equals to income. So when this happens, equilibrium doesn't hold. Okay, so this is what I told you earlier. Okay, let's put it back in the diagram properly. So I have 45-degree line here. I have I plus G here. And if I extend further this vertical line, then we can have S plus tau here. And then we can have our expenditure here. Here we have aggregate expenditure, here we have Y. Here we have C plus I plus G equals to AE. Alright, so W here, W prime here, and then we have Y equilibrium. Alright, now the next thing that we want to look is the stability of equilibrium income. Alright, so the stability of equilibrium income can be explained using graph. So this is the frame of graph. In the first graph, we have determination of equilibrium income using injection leakage approach. So we have real income here, we have aggregate expenditure here. Sorry, not aggregate expenditure. Yeah? We have saving, investment, government expenditure, and then don't forget tau. So we have I plus G here, and we have S plus tau here. So equilibrium is here. I put it denoted as YE. Call it W prime as before. I follow the same notation as before, except that I change this Y equilibrium to YE. Now, for the second graph, we call it phase diagram. It is income over time. So we have real income here, and then we have the change in income over time. Okay, so let's see here. We try to relate it with time. So we have something like this. All right, and we can see here dy over dt, okay, not tau, t times is negative or less than 0, it is downsloping. So we have two phases, the first phase and also the second phase. In the first phase, what you can see here is that it is downsloping, but the value of dy over dt, the value of income, change in income due to change in time, is positive, though it is downsloping, decreasing, can you see? But then here, what we can see is that if we look at the first diagram, we have A, we have B. So in A here, we can see change in inventory is basically less than 0. So we have reduction in inventory, okay? Unintended inventory decrease. That means, because you can see I plus G is greater than S plus tau, so we have unintended decrease in inventory because here demand is more than what we produce. Okay, so we don't have enough output here, not enough stock, so we need to invest more to produce more. So over time, output should increase. Can you see here until it reaches at YE here? So that's how we look at it. Here I have explained to you the left side, which is the first part of the graph 2 and also A in graph 1. Why don't you try to explain the other side of the graph, which is second, area here and area B. Okay, now if we look at injection curve here, this is injection curve and this is leakage curve. Is there any possibility for either one of these to shift? Okay, so let's say we have shift in the saving function. If we have shift in the saving function, obviously it will affect the leakage function here, because it appears directly in leakage function. Okay, so let's say we put it in the form of graph. We have S, tau, I, and G. We have real income here, and initially we have I and G here, and initially we have leakage function here. Okay, so this leakage function, we label it as this. I'm following the notation here. So at equilibrium, initial equilibrium is at y naught. Alright, so let's call it point A. So now, let's say the desire to save increases in the economy. So when saving increases, we know that income can be consumed and saved. When saving increases for a given income, consumption stay constant initially, but then because we want to maintain the same amount of income, consumption has to decrease, isn't it? Alright. Now, in this case, if this happens, what will happen to the graph when income constant? That means saving increases not because of income. Therefore, there must be other factors other than income that can affect saving. So saving in this case shift because of non-income factors or determinants. So when saving increases from S0 to S1. Therefore, this implies leakage function will increase from S0 tau to S1 plus tau, S0 plus tau to S1 plus tau. Anything affect I plus G? No. So here it will shift upward. Let's say to this point, S1 plus tau. And if we hold income at Y0, you can see clearly the excess here by this much. That means we can see clearly at y naught after saving increases to S1, leakage function is more than injection function. So when leakage function is more than injection function, we know that expenditure decreases. One component is C, isn't it? Because income stay the same. So at y naught after saving increases to S1, what we can see here is that leakage is more than injection. When leakage is more than injection, it is very obvious that income is more than aggregate expenditure. Because if you put another approach here in the form of graph that is expenditure approach, you can see this clearly also. Okay, now what happens here is that we have change in unintended inventory, which is positive. Unintended inventory is increasing, overstocking, because output produces more than the demand, total demand in a country. And then we have actual sales less than expected one, isn't it? That's why we have this overstocking. So instead of consuming, households save more. So their demand less, saving increases, expected sales is more than actual sales. So what we need to do here is that because this is disequilibrium at y naught after the increase in saving, then we need to cut the production. Cutting the production means cutting the output in the economy. So output has to move to the left until we reach to the new equilibrium, call it y1, where at y1 equilibrium, because S1 plus tau equals to I plus G, leakage equal to injection at point, let's say X here. So this one is W prime, X here. Okay, so we have equilibrium. This is just one example of the shift in saving function. You can also talk about the shift in other components of leakage and injection. Why don't you try the shift in saving function, the reverse? Okay, I mean the reversed. So try this at home. Also, before I forget, let's go back to this. Before I forget, if you look at this, I mean this. Okay, how to get MPC and MPS? If you can differentiate, okay, like what I did earlier when it comes to drawing, I did differentiate consumption and saving function. So if you differentiate it again here, delta C over delta Y, which is C prime, isn't it? Y minus tau Y, which is positive. This one is nothing else but MPC. So this means delta S over delta Y is actually MPS. And you know that you have MPS plus MPC equals to 1, isn't it? So that means delta C over delta Y plus delta S over delta Y should be equal to 1. Why this one becomes 1? Okay, when you learn in your undergraduate level of macroeconomics, you know that you can have income which can be consumed and saved. Let's assume no tax for simplicity of understanding. Your income can change, therefore your consumption as well as your saving can change. So if you divide this change by change in y, let me fix the right thing here. What you get here is 1. This one is nothing else but MPC. This one is nothing else but MPS. Can you see clearly why it becomes 1? Okay. Now, I hope by now it is very clear, the concept of consumption, saving, leakage, and also injection. But let's go back to this. What I want you to figure out is, now you look here, we have a leakage function given by S plus tau, specifically S as a function of disposable income plus tax as a function of income. We know that when we draw saving and tax here in the graph, it is upsloping. How do you know that it is upsloping? For you to determine whether it is upsloping or not, you have to prove it using maths. Okay? Can you prove this one using maths? I may ask you in the exam. If you look at the textbook, the method used in the textbook is not very thorough. Why? Because it doesn't show you clearly the change in S due to the change in income and the change in tau due to the change in income for every single alphabet in this leakage expression. What I can give you is here is the hint for you to start or to begin with. Okay, you have leakage function here. First, you need to take the total derivative of this leakage function. Step number 1, take total derivative of leakage function. After you take the total derivative of leakage function thoroughly, then you can see in your answer there will be one, common term that you can factorize, and that common term is change in income, dy. You factorize it, you bring it to the left, okay, and then you can get the sign of leakage function. So when you take total derivative, the first step, take the total derivative of this equals to what? Okay, in this answer here, you're gonna see dy. dy here becomes a common factor that you can factorize and then bring it to the left. After you bring it to the left, you decide the answer here whether it is greater than 0, less than 0, or equals to 0. Because the sign that you get here will determine whether it is upsloping or not. Is it clear? I want you to do it on your own, yeah, because this is simple maths. So that means when you learn mathematics for this, try to figure out how to do total derivative. Try to figure out what does it mean by total derivative in this, expression. Why do you need to factorize dy as a common factor and bring to the left? What's the reason? And then after that, once you get the final results, you need to make sure you know how to explain it. Alright? So that's for your homework. We have another special analysis on shift in the saving function, in which this shift can be referred to one type of paradox, call it paradox of thrift. So in order to explain this paradox of thrift using the shift in saving function, we need to have one relaxation of assumption. That is, we assume that investment is a function of income. If we assume investment as a function of income, it will easily explain the paradox of thrift in the form of graph. Now, when investment is a function of income, we need to know its relationship between income and investment. That is, if income increases, what happens to investment? So take the partial derivative of investment with respect to income, and based on a certain theory, we can see that it is positive. Okay, so this one is actually equivalent to I plus Y. All right, now, so you can see it is popularized by John Maynard Keynes. So what does it mean by paradox of thrift? In a very simple, it says what is good for one person is not necessarily good for the whole people in a country or in a village. Now let's say you say to your friend who is very um, extreme in terms of his or her expenditure. He likes to spend a lot and he doesn't care about the future. So you say to him, you better save so that you can still have money in the future. So if you say this to one person, it's good. But if you say it to the whole people in a country, then what happens is that when the whole people in the country listen to your advice, then everybody is saving, nobody wants to consume, nobody wants to demand goods and services in the country, and nobody would like to buy anything from shops. So as a consequence, firms, producer cannot produce more because nobody wants to buy the products. They're making a lot of losses and they cannot hire more labor. The whole people in the country cannot get, employed here. So this is not good for the whole people. It's good for one person, but it's not good for the whole people because it basically reducing the economic growth of that country, innit? Okay, so that is how we explain the paradox of thrift in a very simple way. So, if everybody wants to save more during economic recession, for instance, then it leads to fall in aggregate demand, aggregate expenditures, and enhance economic growth. We can also explain this in the form of graph here. Let me show you in the form of graph. Let's say we have this frame of diagram. And because we know that investment is a function of income and then it is positively related to income. So here we have S, tau, I, and G. Here we have Y. So delta I over delta Y is positive. That means, because G is autonomous plus I, and then because this one is constant, G is constant, but this one is depending on income, which is positive, that means the whole I plus G or injection function is upsloping, isn't it? Okay. Now, what we can do here is that we have I plus G like this, I plus G, okay, and then we have another curve that we need to put, the Kh curve, which is S plus tau. Okay, so let's say this one is S naught plus tau, and initial equilibrium is here, Y naught, and initial level here is S naught plus tau equals to I plus G. Can you see? And then we have many people save money, so saving increases from S naught to S1. So shift upward. Okay, let me draw it properly because it should be parallel shift instead. So like this. Yep, not that parallel. Change it again. Yeah, at least a bit better than before. So S1 plus tau. So if you hold at Y naught, you can see that this issue here, which is similar to the previous one, okay, so the explanation is just the same, but this time, of course, investment here is a function of income. So the adjustment needed here That means because of unintended increase in inventory, because people don't want to consume, people want to save more, so income has to reduce, production has to reduce up to this point. So at Y0, you can see that we have S1 here plus tau, the new one. Now, if you try to compare this with the previous analysis, both analyses, as you can see, we have increase in saving, and both analysis shows us that there is a decrease in income, means we have recession. But then there's a significant difference between this graph and this graph. Okay, so we know that in both graphs, okay, we can see income decreases. Okay, decrease in income that I'm referring to is equilibrium income. As you can see, equilibrium income decreases from Y0 to Y1. So same happens here, Y0 to Y1. But in this graph, you can see that at this new equilibrium level, let me use red, yeah? New equilibrium level, the level of I plus G stay the same, and it's equal to S1 plus tau, isn't it? Stay the same. But if you look here, the level of I plus G and S1 plus tau has decreased. That is because I plus G is no longer constant like this, but it is upsloping like this. That's why there is a decrease in saving level also here. If I plus G is horizontal like this, so we stay the same here. You get what I mean? But now we are here. Alright? So what happens here is that when saving increases, output decreases. Okay, equilibrium output decreases from Y1 to Y0. And the level of saving in the country also decreases. Okay, what happens next is that you must remember in the long term when saving level also decreases with the recession is this, yeah? And that means in the future there is no enough saving for investment in the future, because saving can be used as investment in the future. No investment, no production, no employment, no output produced. So this is paradox of thrift. What is good for one person is not necessarily good for the whole country like this. So I hope this is clear for you guys. We want to look at another component of leakage and injection, which is investment. What happens if there is a shift in investment? Okay, we can also explain this in the form of graph below here. As tau I and G, we have real income here. So let's say initial injection with investment I0 here, and let's say we have initial leakage, which is S plus tau, and let's say this one is a flat one, and let's say we also have another one to make comparison here, the steeper one, S plus tau steep. We want to look at what happens to equilibrium income when investment changes for a given flat leakage or a steep leakage. If you look at the curve of leakages here, steep and flat, obviously it gives you different answer, isn't it? Later we'll see. Let's look at this. So let's say investment increases to I1. This affect injection increases also, isn't it, to this? So there will be a shift, upward shift in injection curve, parallel shift, and this is actually change in investment equivalent to I1 minus I0. Okay, now we want to figure out the equilibrium. I use a black marker now. Initially, equilibrium before change for both types of leakage curve is at y naught. If we start with the same point for both different types of, leakages, then it's much easier to analyze. For flat, the new equilibrium, let's call this one point A. The new equilibrium is at point B, where S plus tau flat equals to I1 plus J. So call it Y1. For steep, the new equilibrium is at point C, where S plus tau steep is equivalent to I1 plus J, and the new equilibrium output is Y2. As you can see, Y1 is greater than Y2, but both of them, okay, greater than Y0, isn't it? So that means regardless steep or flat, shift in investment increases output level. But which one is better? Flatter one. Now, can you explain the process here? I mean, let's forget about the steep. Let's say from Y0 to Y1, how it happens. So because I increases, yeah, so there must be change in inventory. What kind of change in inventory? After that, what happens? After that, what happens until Y0 increases to Y1 and equilibrium rests at point B, higher than point A? So how do you explain this intuitively? Same thing, if I increases from I0 to I1, forget about the flat leakage curve, look at the steep leakage curve. What happens? Equilibrium increases from A to C. But in between, how it happens? Then you need to explain the intuition as well. Okay? And why? The next question that you need to answer is, why flatter leakage give you better economic growth than steeper leakage curve? Alright, so I want you to figure out the answer for all of this. We have seen all the graphs for the equilibrium analysis and economy using two approaches, namely expenditure and also income approach or leakage and saving, leakage and injection approach. But now we want to move to a more analytical analysis because this more analytical analysis can help further in expanding the models because there are some limitations when we use graph to analyze economic variables. Graphs that we can draw, the maximum we can see is three-dimensional graph. But what if we have more than three variables, including independent and dependent variables? Obviously, we cannot picturize it in the form of graphs. Therefore, we need more advanced analysis. In this case, we're going to use mathematical analysis. So, we start with a very simple one. And in this chapter, what you're going to see are basically the things that you have seen in your undergraduate level of economic studies, except that we are using more mathematical notations that perhaps some of you haven't seen before. But actually, if you see the process later, you can see that it is not something new. Okay, so let's begin. So we want to derive the expenditure multiplier. I'm sure most of you have heard the term expenditure multiplier. It is also known as spending multiplier. Okay, so in your previous study, in your undergraduate level or first degree level, we always assume that we use lump sum tax. When we talk about lump sum tax, this tax doesn't vary with the level of income. If you can recall back in our previous slides, okay, like this, and also from the beginning of the slide here, which is this, like this. You look at tau here tax. If you look here, tax depends on income, isn't it? If tax depends on income here, mathematically speaking, the analysis becomes more sophisticated. But we don't want to start with that. We start with a simple one in which tax doesn't depend on income. So tax is autonomous, right? So in other words, it's also exogenous because it doesn't depend on income. And we know that based on our analysis before for equilibrium, the basic equilibrium can be rewritten in 15 here, in which you have C plus I plus G equals to output produced, whatever being spent on the left hand side here, which is the accumulation of C plus I plus G, must be equal to whatever being produced, which is Y, output level. And all of these are in real term. And whatever being received here in the form of income can be utilized as consumption, as saving, and also to pay tax. And let's assume that tax here is lump sum tax. So initially we have tau as a function of income. Now this is no longer valid in this analysis for the time being. Later in the subsequent chapters, you can see we allow this relaxation. We relax the term tax here. We allow tax to be, dependent on the level of income. But for the time being, we just assume lump sum tax. So now, if we take into account T as a lump sum tax, we try to make a notation as T tau bar. Okay, tau, not T. So expression 10 that we had previously, okay, can be rewritten as this, okay, in 16 here. Right. So we want to subtract consumption from each of part here. Okay, on the left hand side we want to subtract it, we want to bring it to the right hand side. So we have this. So instead of C plus I plus G, you have I plus G equals to Y. If you look here, this is Y, but because we bring a C to the Y side here, Y minus C. Okay. Now, we want to derive expenditure multiplier. To derive expenditure multiplier, we have two approaches, either to use expenditure approach of equilibrium or to use saving injection leakage approach. So let's say we use expenditure approach. Okay, so if we use expenditure approach, we know that I plus G, okay, plus C equals to Y. So we omit this bit, yeah, we omit this bit because we don't want to use this. All right, now combination of saving here and tau on the most right side of expression 17, and then rearrange C, bring it to the left hand side, for instance. Okay, this is just a matter of bring left to the right, right to the left. Yeah, it's just simple maths. Then we can have 18 here, we can have expression 18. Now what we want to do here, remember the objective is to find expenditure or spending multiplier. So what should we do next? So from expression 18 here, we need to use mathematical tools to obtain spending multiplier, which is given by 19. This is the final result here. 19 is the final result. But how to, to get to the final result in 19 from 18? Now you look here. Let me rewrite again 18. So we have 18, I plus G plus C as a function of disposable income. But this time, disposable income, we have tax tau, which is a constant because it is a lump sum tax. And in equilibrium, all of them should be equal to real output. And this is 18 that we have seen earlier. Next, what we need to do is we need to use one kind of mathematical tools. Okay, it's similar to econometric tools. Yeah, when you want to present a research, if you have data, you use econometric tools, and then you use econometric software. But if you don't have data like this, but you want to see the interaction between each of the macroeconomic variables here, in which we have I, G, C, and Y, then you have to do you have to utilize mathematical tools. So next, what we need to do here is that take total differentiation of 18. Yeah, so if we take total differentiation of 18, we obtain what here? So you look at this one by one. Totally differentiate y, the symbol is dy. Okay, totally differentiate y. That means d refers to change in y. Total change in y is because of what? It's because of total change in investment plus total change in government spending plus total change in consumption spending. And total change in consumption spending is written as this. If you look at the consumption function here, consumption depends on income, depends on lump sum tax. Okay, so you have to totally differentiate consumption function here. How do we do it? So partially differentiate, okay, delta, yeah, partially differentiate consumption with respect to income, y, and then in bracket, because income doesn't depend on anything else, so totally differentiate income minus totally differentiate lump sum tax. You can see here we have to do partial differentiation of consumption because consumption depends on income. Okay, so that's why we do this. All right, so once we have this, let me label it as 18a. Okay, let me label it as the 18a. As you can see in 18, this is generic function. Okay, so when we have generic function, you don't know the exact number, the exact slope, the exact intercept value, and whatnot. So when you take a total differentiation, you obtain total derivative like in 18a, which is very general. Now, the question here is, when we want to derive the spending multiplier, mathematically speaking, why do we need to do total differentiation? And what does it mean by the results here? After obtaining, total derivative here, what does it mean by this total derivative? It's very simple actually. You do total derivative, total differentiation, total differentiation is the right term. You do total differentiation of an a variable because you want to see how that particular variable changes due to factors or determinants. If you look at this particular case, we want to see how total output, which is denoted as a real income small letter y here, changes due to determinants here. What are the determinants? Investment demand, government spending, and also consumption expenditure by household. So, in a very simple way, let's say, okay, if we say we have change in investment by 10, increase in investment by 10, okay, and then increase in government spending by 5, and then change in consumption here, overall change in consumption here, let's say by 20, okay, what will happen to the change in income here? How much increase in income? Yeah, overall increase in income, is it 100? Is it 10? Is it 25? Okay, so this is what we want to analyze. So it's overall change, the total change. Now let me erase this mask first. Okay, let me write again this G delta Y. Alright, now we do this way because our objective, like I said, is to find expenditure multiplier. If you can recall back the meaning of expenditure multiplier, then you get why we need to go through this. Now, I'm not going to explain to you the meaning of expenditure multiplier now because I just want to show you the calculus part of getting its multiplier. Alright, now what we need to do here is that, okay, if you look here, I just write pen, we can see dy here. What we need to do is we bring this dy to the left hand side. So, okay, take, okay, dy, not delta y, dy to left hand side of 18a. So it yields what? It yields something like this. Let me change the marker pen here. So it becomes something like this. dy minus delta c over delta y dy, isn't it? This is simple maths, yeah? Equals to di plus dj minus delta c over delta y times d tau bar. So let's call this one 18b. Alright, now if you look at this 18b, this is just a simple maths. I bring left to the right, right to the left. So the main point is you need to know the total differentiation method. Now the second step, which is shown in 18b, is just a matter of bring left to the right, right to the left. So this is not something new. We have learned it in the high school. Now what should we need to do now? Okay, if you look at this 18b here, you can see we have on the left hand side of this 18b, we can see we have common factor, and this is just basic maths in the high school, and this common factor is dy, isn't it? So all we need to do is factorize it. Left hand side of 18b. So when we factorize it, we can come up with this. dy in bracket 1 minus delta c over delta y, in it. Okay. Now, and on the right hand side, we have this. Di plus dg minus delta c over delta y times d tau, isn't it? Now let's call this one 18c. Okay, is it clear? Now, we want to see the change in income. Okay, the total change in income due to other factors. So we rearrange 18c such that we can yield this. Rearrange 18c to obtain the following. So we have this. dy equals to di plus dg, okay, minus delta c over delta y times d tau bar, okay, and all of these are in bracket over 1 minus delta c over delta y. Now we try to rearrange it so that it looks like the one that you saw in 18. So dy equals to minus delta c over delta y times d tau, okay, plus di plus dg over 1 minus delta c over delta y. And if you see this one, it is similar to 19 that we have here. Can you see? Alright, so this is actually 19. Now, if we look at 19, on the left hand side here, this is left hand side equals to right hand side, isn't it? Simple maths. dy means the total change in income on the right hand side are the determinants of the total change in income that we have on the left hand side. And this total change in income are basically due to change in investment. How do we know that this is change in investment? Because D means change in government spending. And then what is this? Have you seen this before? If we have 1 minus delta c over delta y is nothing else but the change in consumption due to 1 unit change in income. So if this is the change in consumption due to 1 unit change in income, therefore this is nothing else but MPC. So MPC, 1 minus MPC is what? This is nothing else but MPS. And what does it mean by MPS? The thing that you have learned previously in your first year of bachelor degree. It is the change in saving due to 1 unit or $1 or £1 change in income. And in other words, if you can realize, this is basically multiplier, isn't it? Next, what we want to do is from 19, we want to derive expenditure or spending multiplier. Remember, when we want to talk about spending multiplier, you look at the term spending. If you look at the expenditure approach, we have C plus I plus G, isn't it? And then equals to Y. Okay, now this 19 is the change in income. What kind of income? Equilibrium income. Why it is change in equilibrium income? Because we derive it from this equilibrium identity, remember? So it's not just a change in income, but it is a change in equilibrium income. Now let me bring this 19 into this so that we can always refer to it when we want to derive spending multiplier, specific types of spending multiplier. So we have dy equals to minus delta c over delta y times d tau plus di plus dg over 1 minus delta c over delta y. Alright? Now, if we want to first derive investment multiplier, okay, investment, change in investment affect income. So income will change after the change in investment. Other things constant. If other things constant, then we have to make additional assumption in which DG, there is no change in government expenditure, 0. And there is no change in lump sum tax, D tau is also 0. And because of that, okay, assume DG 0, D tau bar also 0, 19 becomes dy equals to di over 1 minus delta c over delta y. In this case, we can see the total change in equilibrium income due to the change in investment demand by certain amount. Okay, so this is like if I put, let's say, investment demand increased by 10, okay, total change in income would be, let's say, would be let's say, if let's say 1 minus delta c over delta y is, let's say, 2, then this one becomes, let's say, 5. Alright, now, so if there is a change in investment demand by 10, then the total change in income of a country, equilibrium income, will be 5. That's what it means if change is 10. But what if we want to know for every change in investment demand, what is the change in income? This is very simple. Then we modify the formula, it becomes dy over di cross multiply, then we have 1 over 1 minus delta c over delta y. In this case, this is actually for every unit change in investment demand, what is the total change in income or equilibrium income? For every unit of change in investment demand, the total change in income is this much. And this is what? If you can recall back what I said earlier, 1 minus delta c over delta y is actually 1 minus MPC, isn't it? Therefore, it is MPS. So if we have 1 over MPS, what is it? Recall back your undergraduate level. This is spending multiplier. Next, we also want to use 19 here to see what happens to income if there is a change in government spending, putting other things constant. Government spending is a direct component of aggregate expenditure, isn't it? So we also want to see, okay, what happens to income if government put, let's say, expansionary fiscal policy by increasing government spending, what would happen? Alright, now for this, we have the government spending multiplier. Okay, what do we need to, to make in terms of assumption here? What happens to the change in investment? What happens to the change in lump sum tax? And then finally, what is the results? And how to interpret the results? Can you do that? Because now I want to explain to you the third thing using this formula in 19 here, which is this. We want to talk about the change in tax. So if you want to talk about the change in tax, then what should we do? Okay, we want to find multiplier for lump sum tax. So other things constant, assume no change in government spending, DG is 0. No change in investment demand. Okay, then 19 becomes what? dy equals to minus delta c over delta y times d tau bar over 1 minus delta c over delta y. Now if you look here, if there is a change in lump sum tax, how much will be the change in income? Let's say lump sum tax increases by 10. What will be the change in income? It could be 10, it could be 20, it could be whatever, depending on the value of MPC here and also the value of MPS here as a whole, isn't it? And also, you look at the sign here, which is minus sign. What does it mean? If there is an increase in tax, okay, by whatever amount, income will decrease by whatever amount, isn't it? You get me? So that's why we have minus sign here. Now, but what if, again, I am interested in finding out if there is an increase in tax by 1 unit, by 1 pound, by 1 ringgit, what will happen to equilibrium income? And then I just simply rearrange the maths. It becomes this, isn't it? Cross multiply tau, okay, equals to minus delta c over delta y over 1 minus delta c over delta y. Delta is not the same as d because it's partial derivative of consumption with respect to y. Now, if you can see here, still have minus sign. Now you look here, this bit. If there is an increase in tau by 1 unit, income will decrease by how much? By this much. And if you see the numerator here, delta c over delta y, it is nothing else but MPC. If you see the denominator, it is nothing else but MPS. Can you realize this? So dy over d tau bar is actually minus MPC over MPS. Have you seen this before? This is nothing else but tax multiplier when tax is a lump sum tax. That's what you learn in the first degree. Okay. Now, the next thing that I want to show you is balanced budget multiplier. Now, this is number for balanced budget multiplier. Okay, so balanced budget multiplier is a situation where government expenditure is fully financed by tax, and in this case let's assume lump sum tax. So that means if government wants to increase their government expenditure, let's say by 10, the increase in government expenditure is fully financed by the increase in tax by 10 also. Do you get me? So in this case, that means for this year, we have d tau bar equals to dj. Now, call this one 20. We want to substitute 20 into 19. Apart from that, we need to have assumption as well, in which we don't have we don't have any change in investment. Okay, so that's it. So when we do that, we have this dy. Okay, if you can recall back this, delta c over delta y equals to minus delta c over delta y dg. Why? Because we use g for t also, the change in t. I mean the change in t and not just t, not just tau, the change in tau. Plus 0 plus dg. 0 here refers to di. And if you rearrange it mathematically, this is a very simple maths. Okay, but before you rearrange, you can see here, you can factorize because the common factor is dg. So when you factorize, one minus delta c over delta y, okay, dg, isn't it? Rearrange it, then you have dy equals to 1 minus delta c over delta y, 1 minus delta c over delta y dg, isn't it? So here dy equals to 1 times dg, isn't it? That means an increase in government spending fully financed by the same amount of increase in lump sum tax yields the same amount of increase in income. And if we rearrange it, dy over dg, and we can also rewrite it this way, dy over d tau bar, isn't it? Because remember, by the virtue of dj equals to d tau bar, in expression 19, we can write it this way. Okay, now I don't write any sentence to get into this, but you have to put the sentence here like I said just now, so that the mathematics here is clearer. If you don't put any sentence like what I said just now, then your work is not clear in the eyes of examiner and you may get lesser marks. Okay, now let's proceed. Continue with this. We have 1. What does it mean here? Let me erase the mess first, which is this one. This means for any change in G by 1 unit, which is fully financed by the increase in lump sum tax by 1 unit also, the increase in income is also by the same amount, which is 1 unit, 1 pound, 1 dollar, 1 ringgit and whatnot. That's why it is called balanced budget multiplier. So we are done with spending multiplier, tax multiplier, balanced budget multiplier. I hope by now you should know how to do total differentiation. You should know how to find total derivative. You should know what's the reason of doing this total differentiation and how to interpret the results. And also from here, you should know how to derive different types of spending multiplier, including tax and also balanced budget multiplier. I hope starting from now, you start doing some exercises on these chapters. You can find it from the textbook. And please, before you do any kind of exercises, please read and please first listen to this video, second read lecture notes, and third read the textbook. You are required to read textbook because if you don't read textbook, then you'll be having problem in terms of writing proper economic sentences, using proper economic terms, and you are trying to limit yourself to the terms used in lectures only, and that is not good as a master student. So please read textbook. Yeah, so I think that's all. So this is all for chapter 3. Thank you very much.